Hi, everyone. Welcome to today's webcast, How the Cloud Breaks Traditional Security Approaches. My name is Amy, and I'm on the marketing team here at Lacework, and I'll be your moderator today. Before we get started, just a couple of housekeeping items. This webinar is being recorded and will be available on demand after today's live presentation. Also, on the right-hand side of your screen, you should see some related content to today's topic. Feel free to download any of these to take with you. This webcast is also meant to be interactive, so feel free to submit any questions via the Q&A box, and we'll save some time to answer these at the end. Otherwise, let's get started. With me today, I have Abner Germanow, who is our VP of Product Marketing here at Lacework. Over to you, Abner.
Great. Thanks, Amy. It's fun to be here with all of you on a day when lots of things are working and some things aren't, so thanks for bearing with us. I'm here to talk to you about how cloud breaks the way that we've done security in the past. And before I dive into that, it might be helpful to just talk about why I have a clue about this. And so just very briefly, I've got a long history in market research at IDC. I ran the security program a long time ago. I worked for a company called @Stake, which was a premier security consulting firm way back a long time ago, and people from that firm are now running security in all sorts of interesting places and building really cool security products in a number of places. Then I went back to IDC and spent a lot of time covering networking and communications and collaboration. Took that and went to Juniper and built data center fabrics because the application architectures were changing. And not only were application architectures changing, but this thing called cloud was starting to be a really big deal. And so from there, I went to a company called New Relic, which does application and infrastructure monitoring. And really, it was the leader and still continues to really push interesting innovation in the way that you monitor applications at scale. And I spent a little bit of time at a serverless development platform called Stackery, which basically has a AWS development platform for people who are building serverless apps. And now I'm at Lacework. So what I'm going to do today is talk to you about what I see in the market, but also a lot of this is essentially why I joined Lacework fairly recently and some of the changes that we see in the market. So I'm going to spend a little bit of time talking about where cloud security teams spend their time. Then I'm going to move to five different ways that the market has shifted and very new ways of dealing with security in the cloud and why what we used to do doesn't work anymore. And then I'll spend a little bit of time at the end just talking about how Lacework solves some of those problems. But we'll keep that part really short. So let's dive in here. Whoops. So one of the things that we see when we're looking at infrastructure security is that infrastructure security in a cloud world doesn't look anything like infrastructure security in a data center world. You have teams of people who work in cloud accounts instead of in physical data centers. They're working on microservices with CI/CD pipelines where they're making changes all the time. Those microservices, the CI/CD pipelines, and the services that they're using all talk to each other over APIs. And all of this is sitting on infrastructure that's scaling up and down constantly. And so we're going to dive into to each of these pieces quite a bit. But let's move now to thinking about where cloud security teams spend their time. So when we think about where would we like to spend our time, one place where there's a lot of movement today is in the sort of shift left movement and building in a secure fashion from day one. So the amount of time that people spend on application security has gone way up. And just thinking about how do you build and configure all of these services in a secure way with all the guardrails. And so a lot of time being spent there. And then, of course, there are all the different actors in the cloud. So this could be the people, the services, the configurations, all the different ways that they interact, and all of those produce data. And so that data, generally, we're going to pull out of the infrastructure in various ways in order to understand what's happening. And so when we think about what does that data look like, and more importantly, what do we actually do with it, the next step in any kind of infrastructure, and whether you use tools to do this or do it fairly manually, there's an effort to make sense out of that data. And how do you organize the data in such a way that you can make sense out of it and start to make decisions? And so a very common way of moving from that raw data to organizing it is to run it through rules that I have to write and then tune over time, or maybe I take that data and I shove it at a machine learning algorithm or something along those lines to start to make sense of it. But the larger my cloud environment is, the more data that I'm pushing. And so this is a fairly noisy area. People are pushing a lot of data into a variety of different security tools and log managers and SIMs. And so once you've started to organize that data in your tools and environments, then you actually want to start analyzing it. And the analysis of that data is where people spend a lot of their time. And there's this loop of activity that occurs between taking that data in, trying to figure out whether it's useful, writing rules that generate alerts, understanding what those alerts are, writing suppressions on things that are noisy, and then doing analysis on this. And so this loop of activity is often is what we call the circle of security data toil, because you're going to spend a lot of time there. And last week when I was talking to a customer about this, he called it the mean time to WTF. I love, because it's just how long does it take you to figure out whether something is interesting or not, whether something is worth spending more time on. And that ability to just understand what is it that I'm dealing with often takes quite a bit of time, given the amount of data that is coming out of all of our various cloud environments. And so then once you've figured out what's actually happening, then it's time to actually make decisions on that. And so when I think about what sort of decisions you're making, you could be making decisions around should you mitigate something? Should something go, be prioritized in the roadmap? Are you ready for an audit? Should you continue to investigate? Have you built up enough investigation and evidence that you're going to prosecute someone? But basically, are you going to continue with going around that circle of security data, or are you going to stop? And so if I think about where people spend their time, people spend a lot of time in the circle of security data toil, and of course we want to spend more time making decisions about that data, and we want to spend more time helping people build and configure properly in the first place. One thing that also hasn't changed is that the amount of talent, security talent in the market is just very, very narrow. One of my favorite stats is that the unemployment rate for security people has been 0% for the last 4 or 5 years. And so that tells us that there's a lot of talent out there that needs to be nurtured and optimized. Okay, so let's move to the things that have changed. And one of the big things that's changed with the rise of cloud is what I call the SpiderMan rule of cloud service adoption. So what is this? Well, this is essentially the classic line of SpiderMan: with great power comes great responsibility. And we all know that the cloud is filled with tons of services that are always evolving, and those services are awesome. And so when we think about what those services can do for us, the ability for those services to both do wonderful things and harmful things, and sometimes they're all in the same. The Amazon S3 is really the poster child for this, but it's certainly by no means an orphan in that regard. So Amazon S3 is both secure storage and a web server, which is simultaneously awesome. I mean, S3 is arguably one of the best cloud services ever. It has really set the tone for every cloud service. It's scaled longer. It has been, its uptime numbers are incredible. And when it went down, I don't know, 2 or 3 years ago now, whenever that was, it was very clear how much of a part of the fabric of the internet it has become. So it's this awesome service, but also there's an award that's given by a guy named Corey Quinn, who gives out these S3 Bucket Negligence Award in his newsletter weekly. And so what that tells me is that there's a lot of people who still haven't gotten this right. But, this is one thing that everybody has to deal with, is the fact that they're dealing with a very, very powerful service that also requires a fair amount of responsibility and oversight. And so the thing that's new is, or the thing that we used to have to deal with, is sort of controls and guardrails while balancing innovation and speed, because there are lots of different services that are always coming online, and how do you simultaneously use them well as make sure that your developers have access to all those new services and can move quickly and serve your business as fast as possible. And so in a world where we used to be able to put controls and guardrails around things and really restrict the number of services and the capabilities that and adopt new services in a very thoughtful way, now you have kind of this wild west of innovation that's awesome for the business, but from a security standpoint presents a lot of fear for people. And so the way out of that is that you have to monitor for normal behaviors and anomalies in these new services that are constantly changing every day, if not every hour. And that's a new place for many security teams. Okay, so let's move to the next problem, which is if you think about this effort to monitor and understand those services, how do we actually do that? And historically, the way that we've done this is to write rules. The problem in the cloud, however, is that the process of writing rules is really broken. So when I talk about a rule, what am I talking about? Well, very simply, if something happens, then send an alert generally. Or if somebody like Carl does something constantly, then I'm going to potentially suppress that and say that, if something happens, then we'll just let Carl continue to do it. So, or maybe that's an automation tool or something along those lines. And so in the security world, we have this long history of writing rules to enable alerts and to understand the behavior. And there are really two different models to do this. There's the negative security model, which is basically I define a threat and then I allow everything else. And then on the positive security model is essentially the opposite of that, which is I define what's allowed and deny everything else. And both of these have pros and cons and are useful in different ways. However, in the cloud, what do you need to know in order to write rules? Well, first of all, you have to have a deep understanding of every single cloud service API and how each of those services interact. So if you think about something like an S3 that might have 100 different APIs times 100 different services, that alone requires an unbelievable amount of knowledge that no single human possesses. But let's just pretend that you can know all of that. And then the next piece is you also have to be an expert in the tools that you're using. And then finally, you have to understand your own environment and your own applications very, very deeply. And of course, no such human actually exists. And so when you think about, even if you were to know all of those things and you had the entire encyclopedia of known threats or known acceptable behaviors, and you were somehow able to keep up with that over and over again through every change that occurred, you would still miss the unknowns. You would miss the new things that show up. You would miss the new service or the weird thing that somebody did because they were trying to solve a problem in the business in a very kind of haphazard way. If you didn't know a couple years ago that Bitcoin mining on EC2 instances in compromised accounts was a thing, then the first couple times you see that, like, you wouldn't know what you were looking at. And so understanding whether or not moving beyond just the known bad actors into the unknowns is pretty new. So we have to remove humans from that rule toil. And when we think about what does that actually take, we realize that, wrong slide, that's all right, we'll just go with it. So you have a set of instrumentation, and then you have outcomes that you want to push from that. And let's just keep moving. All right, let's move to, so that thing that we have to do is we have to know the unknowns, and the reason why that's important in this environment is because you have to adopt new services. If you have a large team, they're going to adopt new services, and given the very small number of people on your security team relative to the number of developers and other engineers, you don't want that small number of security people to be a bottleneck in the process. So connected to this is the fact that historically in security, we spent a lot of time on network data. But in the cloud, network data isn't your only friend anymore. It's not the thing that you're going to use. And so if you look at a standard architecture, IP addresses alone don't tell you a whole lot. In a historical data center, you could put a firewall in and get a pretty good view of what was going on. You understood what you lived in your data center, what the applications were, and you could essentially infer what was happening based on network traffic, and network traffic could tell you a lot. But if you look at just a very simple microservice architecture and what that entails, the only compute in here is the Amazon ECS, the container service, and you're accessing Amazon S3, you're accessing a number of different services, and if the attacker or somebody does something weird in any of these services, you don't have any view into the granularity of that activity. So if your attacker is using Amazon S3 and your application is also using Amazon S3, the network traffic running to S3 isn't going to tell you a whole lot. You have to go deeper than that, and you have to understand what's happening at the API and the process level. So for that ECS instance, you have to understand what kind of relationships does it have with all those other services, who's making changes to that, and what those behaviors look like, not where did the network traffic go. So if we think about what would we like to have happen, if you've ever played the board game Clue, essentially what's happening in the cloud is that every hour you're playing a new game, and understanding the view into those relationships over time is super important. So for example, what we want to know are things like, what did Colonel Mustard do with Netcat in the database? And that relationship between Colonel Mustard, Netcat, and the database is the important part, not what network traffic flowed. Network traffic might help us figure that out, that was the relationship. But what I really want to know is, what did that user do? What tools did they use? And what services did they access? And maybe what else did they do? Because an hour from now, it's going to look something like this, where instead of in the database, it's in S3. And so if you think about what might this look like in real life, in a real environment, it looks something like this. So this happens to be a Lacework relationship map that we call a polygraph, which shows us the relationships between all the different application components as they scale up and down. And in this particular case, we're showing a comparison between what happened an hour ago and what happened in the current hour, and understanding what those relationships are, how they change as new services come online, as they scale up, as they scale down. That's the piece of security that we need to know now, is the relationship, not the individual action that occurs on each of those entities, although it's handy to have that as well. So what I need to be able to do now is move from an instrumentation and think about what kind of instrumentation can I get beyond the network. So can I get configuration messages? Can I get usage logs? Can I take the vulnerabilities that I have? Can I instrument my pipelines? Can I instrument the processes that are running inside my containers and instances and anywhere else? What's happening to the files? Are those changing? What are the network connections and the DNS? What does that tell us about all those things? And so thinking about how deeply you instrument in order to surface those relationships is something where, from a network security standpoint, you have to think a lot more about how you get all that data and then how you process it. But we definitely have to move beyond network data. So the next thing we're going to talk about is an explosion in AWS accounts or cloud accounts. So historically, in a data center environment, you would have a production environment, staging, and maybe a couple other environments that were highly controlled. And you went from a developer's laptop to those environments, those physical environments in your data center. But today, everybody has their own accounts, and the number of accounts in every environment continues to go up. So it might be accounts based on a particular service, might be accounts based on a particular team, or it might be accounts based on a particular developer. So we've seen a number of those different models where basically the number of accounts increases all the time. And if you think about how do you understand what's happening inside that account, the number of accounts that you have and the number of users and the number of cloud resources that are in each of those accounts, that complexity to understand what's happening in all of those environments all the time is an exponential problem. And so one of the things that we see in very large environments is, you can kind of get a handle on what's happening at a small scale, but as soon as you get to 50 to 100 engineers and over 10 accounts, humans can't deal with it, and you end up with very large log environments that are super hard to analyze. So what are your options here? Well, if you're trying to figure out what's happening, one way that a lot of people figure out what's happening is that their finance department comes to them and says, "What's this?" And so if you get lucky, you're on about a month delay, and you have a finance team that's looking into strange things. Another approach is to look at known issues. So you can go write rules in Splunk, use Sumo Logic. You can use a tool like Amazon GuardDuty or Redlock or some of those that essentially helps you write rules and tune that account to understand what those known bad actions are. Once again, then much of the onus is on you to either write those rules, or you're getting kind of one-size-fits-all rules that don't necessarily fit your environment and what's normal for you. And so that's all great, but it also is limited to that known threat universe as opposed to understanding the unknown threat universe, and that's where Lacework really shines, is understanding that unknown universe as well as the known universe. So the last big thing, or second to last big thing that changes is what we call blockers, or no, this is the last one. The last big thing that change is the blockers versus pipelines. So what do I mean by that? Well, historically, when something bad happened, what we wanted the security tool to do was to block and remediate it. So, you'd have this classic example of, we found a vulnerability, let's shut the service down and automatically remediate it to get it back up and running. That's in direct conflict with the DevOps pipeline that pretty much everybody is building today. So every service has its own trail that it goes down, and you might have the biking trail on the left and the walking trail or walking service on the right, but every service has is headed toward having a common pipeline. And the security teams need to follow this environment. And so when you think about, is security allowed to break the build? Is security allowed to block something? That's actually a fairly complicated question of where do you want to block a vulnerability in its path to production. And so one of the conversations that we have with customers all the time is, how do you figure out what the right place to block, the right place to engage in your pipelines with the individual service teams, and understanding how their vulnerabilities and how you can prevent those vulnerabilities from getting into production. And so this is a place where security can no longer act as a silo, but rather has to really be part of the team. And of course, there's a term for this, the DevSecops movement, and it has to be for real. So you really want your security talent moving into advising on application security and developer guardrails, but you also want to be able to prioritize real vulnerabilities. So you scan something, you might get lots of results of lots of different vulnerabilities in lots of containers, but what really matters? What's actually running in production? And then other things like, if there's an incident or an outage, is it a security incident or is it some other problem? And the ability to validate or refute whether or not an outage has a security element to it or not, and doing that very, very quickly is really a big part of working with the larger team. Okay, so with all that, there's a lot of change in there. I want to talk about a little bit just like how Lacework fits into all this, and then we'll move to questions. So we spent a fair amount of time talking about how the sort of daily life of a security team hasn't really changed in the last couple of years around cloud. If anything, it's gotten worse in terms of how you deal with all of that data. And so how does Lacework deal with this? Well, we get you out of that toil. So one place where we can help you throughout this life cycle is in scanning your container registries for vulnerabilities, and connecting you with APIs and connecting your pipelines with APIs that can tell you whether or not you have vulnerabilities, and then move to helping with those. The second place where we help you is in collecting the data across your cloud estate. So we can plug into a number of different places, both from logs to having a very lightweight agent, and that's a conversation that you also want to be having with your DevOps team in terms of how do you instrument that environment, what's the best path to be able to do that. Now, one place where Lacework is very, very different is how we organize the data. And the way that we organize the data as we ingest it is in behavior. So we take that raw data and we turn it into a behavior. What does that mean? That means that we understand all the chain of events that occur either through users or application relationships, and that's where we start. We take that raw data and we turn it into and we organize it into behavior. So this maps the truth of what happens in your environment, and then we do that over time. And so which allows you to compare those things over time. It also allows us to run machine learning on that and understand whether or not there are changes in there, and whether or not those changes are anomalous. Or we can also run rules against those changes. So here we have an example of two sets of changes that Alice made. So Alice on the left SSH'd into a host, made a package change, and then left. And that's a very common activity that Alice probably does multiple times a week, or an automation tool might do on a regular basis. And so, if we're looking for sudo in our rules, we might just suppress Alice and stop looking there. And so now we have a blind spot for Alice. But if Alice on the right goes and fires up Hydra and goes and exfiltrates a password file, we won't see that because we've suppressed Alice doing some of that activity, or at least a rules-based approach wouldn't do that. Lacework, on the other hand, would see that not because we were necessarily looking for Hydra, but because that's a very unique behavior for Alice, and we'll be watching for that. So what that allows you to do is to use the data that you have to make decisions. So for example, the alerts that we send give you generally about the first hour and a half of a investigation in the alert itself. So the alert itself can tell you what happened, why did it go, and where do we and who did the work, what was the relationship, why did we send the alert in the first place. That allows you to dig very quickly into what else happened, what else is running on that machine, what else is that container doing, have we seen anything else that's similar to this, and you can do that very, very quickly. It takes me 2 minutes to do it, just clicking through, as opposed to building a set of queries in Splunk or Sumo Logic or a place like that in order to understand what's happening or what happened there. And that allows you to conduct an investigation very, very quickly. In a similar note, we can also take that data and figure out whether or not it helps us, it provides what we need to pass an audit, or we can take the data around vulnerabilities and what's live in order to prioritize a fix in the roadmap. So, and that's just a bit that I just said for the recording afterwards and for people who just flipped through. So with that, I'm going to turn to see if we have any questions, and then we'll go from there. Amy, do we have any questions?
Like we have a couple, just a moment. Let's see, so Abner, you mentioned that the move to the cloud changed the way that DevOps and security are currently working together in today's modern environment. Can you just touch a bit more on that?
Yeah, so I think there's a long history in security of what I would call corporate risk management and kind of back office IT management, and those pieces are really important. We also see this rise of security professionals who are part of the product team. So oftentimes they'll report to the VP of engineering, and their role is to help enable the organization to deal with sensitive data, to understand threats, to manage investigations, and to really be a core part of the business itself. And so when you think about what's possible in a business where they feel confident in their ability to deal with sensitive data, to understand their infrastructure at a level that's very deep, and understand what the risks are with that infrastructure, that shift to really being part of the revenue side of the business, as opposed to being tinfoil hat people that run around sort of scared of the world, that's a big shift in the environment. And the DevOps teams, the product teams are really driving the business in many cases. And so the security professionals that are part of that engage in those conversations and really be part of that team, those are the ones that we see getting promoted and really moving to be builders and trusted partners inside those organizations.
All right, thank you. Let's see, the next question is around compliance. So it's around, I'm struggling a bit with compliance. I understand that rules are hard in the cloud and they can get in the way, but I also use them to support compliance reporting. So how would you, Abner, best recommend to do that within a cloud environment?
Yeah, so I mean, there are a couple of different challenges in compliance. One is there's the understanding, are your configurations correct and those pieces, and that's, there are a lot of different tools that can help you with that. Lacework's one of them. Those compliance capabilities and just understanding, are you compliant? You can no longer be compliant at a point in time. You have to be constantly compliant. And so understanding how your compliance posture changes over time and being able to show data from the last several months or the last year to an auditor is a big part of a cloud environment. If you're in a sort of historical environment that's fairly static and isn't changing a whole lot, then point in time is good enough. Now you have to be able to prove that you've been compliant over time. And then on top of that, not only do you have to prove the configurations, but also a number of different processes, and then being able to show what you can do in the environment, what you have visibility to. You have to be able to show that you know what all the users did, and being able to show that data very, very quickly, as opposed to we know it's there somewhere in a log file is where auditors are going. And so the ability to both prove over time as well as show that you are actively analyzing the data in a way that's useful and actionable is where a lot of compliance auditors are headed, and that's a really important aspect for any business where their customers are insisting that they have to be compliant to various standards.
Thank you. And looks like last one here is just around a comment of liking the notion of shifting security left and right. That a lot of vendors are saying shifting left, but shifting left and right. So could you just touch a little bit more on that, and then what activities do you find folks that you guys know and your customers, what are they able to devote more time to, kind of given this practice?
Yeah, so when I was on the phone with a customer last week who said, yeah, I haven't written a rule in a year. And so the fact that they're out of the business, here's a payment credit card transaction company that is out of the business of writing rules and tuning alerts, and yet and now is very confident in what they're doing as they scale up more and more applications in the cloud. They're now spending much more time on application security and on what does the pipeline to production look like, as well as spending time on investigating what I would call high-quality investigations instead of low-quality investigations. And so by taking a fairly small team, I think they have 8 people, they now spend much less time on just understanding what's happening and much more time working with the other stakeholders in the organization to empower the business.
All right, thank you. And looks like that's it. Abner, thank you so much. And yeah, feel free to share your information, Abner, if anyone has any questions. Go for it.
Great. Well, thank you so much for joining us today. I'm Abner G on Twitter, and tell us what you think. We're always love talking to people. So take care, and if this looked interesting, definitely give us a shout, and we'll get you up and running.
All right. Thanks, Abner. Thanks all.